modulus of elasticity. I've already seen the Hooke's law, right? The Hooke's law and modulus of elasticity has a relation. Let us see how. You can see again there is a stress strain curve. I have already explained you that till elastic limit in this zone, stress is directly proportional to strain. If I want to equate it, then a constant is added which is capital E. If strain goes below the stress, then modulus of elasticity is the constant E, is stress divided by strain. So E is called as constant of proportionality of the material. It is also called as Young's modulus or modulus of elasticity. It is named after the English scientist who is called as Thomas Young. Strain is unitless. If strain is unitless, then the unit of modulus of elasticity will be same as the unit of stress, which is Newton per mm square or kilonewton per meter square. It can be anything which is given according to the load which is being applied. Let us solve one more numerical on modulus of elasticity. Now, if there is a rod which is of length 1 meter and it is having 20 mm into 20 mm cross section, then it is subjected to a pull of 10 kilonewton. Then elongation of rod is 0.12 mm. Then we need to find out the modulus of elasticity. Let us start. There is a rod which is of length 1 meter. It is given over here. I'll have to do the conversion. So it will become 1000 mm. Now there is a cross section area A. So it will be 20 into 20, which will become 400 Newton per mm square. There is an axial pull. So pull means a force. So P is given as 10 kilonewton. I've told you we need to do the conversions. So kilonewton will be converted into Newton. So it will be 10 into 10 raised to 3 Newton. Elongation is given, which is delta L, which is 0.12. Now this is the given data. So let us start with the numerical. Since force is given and area we have found out, so we can easily find out stress. Stress is equal to force upon area, which is 10 into 10 raised to 3 Newton divided by 400 mm square. If I'll do the calculation properly, I will get value as 25 Newton per mm square. Same way, length is given and extension is also given. So I can easily find out linear strain, which is delta L upon L. Delta L is 0.12 and length is 1000 mm. So if I do the proper calculations, I'll find this value as 0.00012. I'm not going to write down the unit because the strain is a unitless parameter. Now the ultimate thing which I have to find out is modulus of elasticity, and in the previous slide we have already discussed that modulus of elasticity is stress upon strain. Stress I have found out, which is 25. Strain I have found out, which is 0.00012. If I do the proper calculation, then the value turns out to be 2.08 into 10 raised to 5 Newton per mm square. So finally, I had to find out modulus of elasticity.